Okay, so I want to start by taking you back to sort of the origins of observability. This is the original where dashboards come from, the caveman just sort of carving everything in, worried about the time where that person's going to come up and say, can you add auto refresh? I jest, but ultimately, observability, OpenTelemetry as a mechanism for that, observability itself isn't new. We've been doing this for a while, we've been observing systems. I mean, really that was really the sort of OG, if you like, of observability, which was the blinky lights. I was told recently, does everybody know what these things are? Because I've found out recently that there are some people who've never seen one of these. These are called servers. There's lots of them in the cloud. But ultimately, when we started out, we had these in the end of our office, and they'd have blinky lights on them. And if the blinky lights went fast, you were earning lots of money. If they went slow, then they were not earning money. And if they went off, then you'd call somebody to come and fix it. Like, it was all built in. But anyway, so my name is Martin Thwaites. I am first and foremost an observability evangelist, or activist, some might say. I am also a now principal developer advocate for Honeycomb. You may have heard Honeycomb this morning. Charity is our CTO and was here doing the keynote. So hopefully you got a few bits about what observability is out of that. So I'm not going to rehash a lot of what observability is. If you would like to hear things that are going on in the OpenTelemetry community with a slight of token British snark on top, follow me on social media. I go by martin.net in all the places. Anyway, right. So I want to start in something a little bit more modern that I would imagine quite a few people here are familiar with. Now, around the 2000s was a time when metrics ruled the world. That's what we had, it's all we had. It's the only thing that we did for our production systems. We'd have metrics. We'd have tools like this. Does anybody know what either of these two tools is? This isn't a drinking game. We're not going to do shots whenever the tools come up. So on the left, Cacti, and on the right is MRTG. Now, these were tools that we were using to understand what was going on in production because our production systems were simple. We'd have a few graphs that would tell us the network rate that's coming in. Maybe we'd have something that would tell us the memory usage. But we didn't really need much because our systems were quite simple. We also had a lot more rigorous testing, and things wouldn't go out for 4 years. And yeah, they always failed then in predictable ways, so we could build metrics around them. Now, if you want to fast forward about a decade, around 2012, 2013 was when we started to move on from these kind of tools that were based on fixed size databases. We had things called RRD tool, where metrics were stored. Not only did we restrict the context, the additional labels, we'd also, as time went on, we'd compact that data. And it's the idea that I could view what happened every second for the last hour. I'd be able to review what happened every minute for the last day, every day for the last month, or every month for the last year. But you couldn't go back, way back, 2 months and say what happened at 3 seconds past midnight on June the 6th, because we didn't have the storage space. At this point, in the 2000s, hardware was expensive. Whether it's RAM, CPU, storage space, my first hard drive was 70 megabytes. Dates me a little bit, I'm sure. And I'm sure there are people in the room that can outdo me on that one. This isn't a challenge. So in 2012, because we started to need this kind of data, we needed to go a little bit more granular over bigger time frames. We also started to store things on servers that were cheaper. And around that sort of time, we came up with 2 competing tools. We had InfluxDB and Prometheus. They're still around today. They're still very, very popular tools. What they are time series databases. They're databases that store a metric data point with labels associated with them, and they scale in particular ways, they work in particular ways. Now, around that time, we also moved into this, which is my favorite tool in the world for 2 reasons. First, the name says exactly what it does. It's a tool for stashing your logs somewhere. So they called it Logstash. The second one is the icon tells you exactly what the company is called, what the product is called. I do believe that now we have kind of lost our whimsy when it comes to this kind of stuff. In Honeycomb, we haven't. We have all the stickers. The stickers at the end, you can come and get them. But we had Logstash, and Logstash was a tool that allowed us to be able to take our logging data and store it in a different location. Generally, we'd pair this up with something like Elasticsearch and Kibana, or Kibana, depending on how posh you are. But we'd store it in a structured data store. We were using Elasticsearch to be able to graph this data and be able to query it. It was like the first time where we started to think about the fact that the rich context of logs, where we'd extract them and give them structure, was actually really important. This is Kibana, part of the Elasticsearch stack. It was called Elk, for those that are too young to remember, which makes me sad that there are people who don't remember Elk. This is a more modern version of it. It didn't look that pretty back then. But ultimately, it allowed us to query data, and it was a revelation for a lot of people. Because now, all of a sudden, we don't have to pre-aggregate things. We don't have to think about how we're going to query something before we actually write the data, before we write the code, which was really, really groundbreaking in a lot of ways. Now, fast forward another 5 years, and we're into 2017, which is kind of the birthplace of sort of modern observability, or Observability 2.0, is where things started to formulate into what Charity was talking about this morning. Now, around that time, we started to understand that systems are different now. What we were doing in the 2000s, where when I started, the architecture diagrams were box, line, cylinder. It was an application and a database. It was easy to understand. There was one of them, and it was over there in the corner of the office. By 2017, we're talking distributed systems, event-driven architectures. We're talking about replicated services over massive, massive infrastructures. And two tools emerged, OpenTracing and OpenCensus. What they were doing was distributed tracing. It was allowing us to understand how a complex system works in real time, in our production systems. Now, the problem was that when you acquire a new company or you start a new piece of software and you go, I'm going to use OpenTracing, but the rest of the business is using OpenCensus, the two tools didn't interrupt. They were different standards. So around the 2017 time was these really smart people came together and went, well, we've got two competing standards. What we need is one standard to rule them all. And we all know where that ends up. However, OpenTelemetry is the exception, because 2 years ago, OpenCensus and OpenTracing mutually deprecated themselves. And OpenTelemetry is the one true standard for distributed tracing and some other signals. And we'll go through what those equate to. But that was a sort of golden period, really, where OpenTelemetry was quite fledgling at the time. We were working out what it should do. We were working out the different facets, the things that made it great. So what exactly is it? Now, it is the #1 project coming out of the CNCF. It overtook this little thing they did. Was it something to do with containers? Kuba something, I don't know. Apparently it's pretty popular. OpenTelemetry is now the #1. It is the de facto standard for how you emit telemetry signals from your application now. It's not the only way to do it, but it is the de facto standard. I've joked a lot where it used to be the IBM. Nobody gets fired for buying IBM. Well, nobody gets fired for suggesting they move their telemetry to OpenTelemetry now. Maybe 5 years ago, it would have been, what do you mean? Re-instrument all my code in an open source thing? No, I'll just use a vendor and install an agent. But nowadays, that isn't the case. We've got stability and various different things inside of OpenTelemetry that mean it's just not a no-brainer anymore. So the thing that makes OpenTelemetry incredibly useful is the protocol. OpenTelemetry is a few different things, but the protocol is one of the most important aspects. Because the protocol is what allows us to be able to not know in our application where we're going to send our data. We don't need to know what vendor we're using. We don't need to know what backend, what open source backend we're sending that data to. Because the protocol defines the data model, the API contract for the various different signals that come out of OpenTelemetry. It's one of the reasons why the vendors are so on board with it, because it means that if we all accept the same data format, we don't need to do the work in the applications. That's what the open source projects are for. It allows everybody to have choice. It allows you to have and hold your vendors to account, your backends to account on their innovation. Because it's no longer, oh, right, yes, we're going to renew your renewals 300% of what it was last year. And you're like, I'll move. And they're like, good luck. 1,500 machines you've got. Good luck installing a new agent on 1,500 machines in the next month. With OpenTelemetry, you can turn around and go, it's 3 lines of config. I'll send it to a new vendor. And they're like, okay, maybe we'll just do it the same price as last year. That is why it is so powerful. It's also the reason why, if you've noticed over the last year or two, the amount of observability vendors that have just come out of the woodwork and set up new businesses, different ways of analyzing telemetry, different niche use cases. The reason why all that works is the OpenTelemetry protocol and also the OpenTelemetry SDKs. It's because none of these vendors, none of these backends, even whether it's open source or a paid product, have to think about how you're going to actually instrument your application. You're not trying to convince somebody to re-instrument their application with your code. You're asking them to re-instrument with an open source library that can send it to any vendor, to any backend, which is why it is so powerful. Now, there are some core signals that are part of OpenTelemetry. We have traces, metrics, and logs. Now, it is not spelt P-I-L-L-A-R. There are no pillars here. There are signals. There are no pillars in OpenTelemetry, just different signals, the different data models that represent different types of data. Traces, metrics, and logs, the core signals, they are all stable across the 11 different languages that OpenTelemetry supports, from Java to Rust to Erlang, and everything in between. Now, there are 2 other signals that are being developed at the moment. We have profiles, which is a low-level, kernel-level calls to do micro-optimizations. At this point, we have a protocol. We have a data model. It's all signed off. What we don't have is how the SDKs need to work and how we need to put this in applications. That's coming, probably sometime early next year. And then we have RUM. It's the bad kind of RUM, not the good kind of RUM. I'll be having some of the good kind of RUM later. This is real user monitoring, which is the idea of client-side, living in the browser, living in a mobile app, and how do we represent that data, which means it's a little bit different to tracing and logging data because we've got things like sessions. One of the biggest problems with OpenTelemetry is there are lots of people and lots of committees, which means things take a lot of time. But it is something that people are working on. It's something I get asked quite a lot. It will get there. So let's look at these individual signals. So what is a trace? Well, traces are about debugging. That's the reason for existing, is to debug. It's for you to understand your complex system, give you an overview of how that system is interacting, all the different services, why they're being called. You can use that to build things like trace waterfalls, service graphs, because it's describing how that complex system of services interacts in order to service a user request, to do a user action. It has a focus on causality. It has a focus on being able to say that this thing happened because this thing happened before it. Now, we can do that with logs, for instance. We do that using the event timestamps, and we try and eyeball between 2 different timestamps. But I have a question. How many people have synced the time on their servers in the last few months? I thought so. We don't do it. And when we're talking about high-performing systems where a request can take 10 to 15 milliseconds sometimes, a millisecond here and there actually counts. So you saying this thing happened first, it might not have. It might have been that thing that happened first, but the times are out of sync. Causality in a trace allows you to be able to see that. Now, it also has a focus on performance because each span within a trace will allow us to be able to see a start time and an end time. But it also has high dimensionality, and also high cardinality in each of those dimensions because it doesn't care. The data model where we're storing it doesn't care. Now, we don't actually create a trace. There's no API that says var trace equals new trace. We don't create a trace. What we do is we create spans. A trace is a group of spans with the same trace ID. So what is a span then? It's essentially just a structured blob of data. It's not that special other than some things that it has on it. So it has a unique ID, has a span ID, we call it. It has a correlation ID. That's not new. People have been doing correlation IDs for decades. We've got requests going through the system. Let's just add a header. And we'll add a correlation so we can add all of our logs together. It's not new. We call that a trace ID. It has a start time and an end time. But the thing that differentiates it from logs really is this thing. It's the causality ID. The thing that happened before it is what allows us to build things like service graphs. It allows us to represent things as a trace waterfall. It allows us to be able to visualize how that request was serviced by different systems at different times, pinpoint performance issues, and why they happened. Now, the other thing it has is a big bag of attributes. That's our dimensionality. Now, a lot of those attributes will come from what we call the semantic conventions, which is the easiest thing in computers. It's all about naming. It's the reason why it takes so long. It's basically like 100 different people deciding on naming. It's everybody's nightmare in IT. But what we have is semantic conventions which are signed off names for what they mean. So you don't have to have those arguments inside your organization. Some of them will come from that. Some of them will come from your data, your context. You might be dealing with a multi-tenant system. So you want tenant ID on there. You might be dealing with user IDs. You'll add user ID on there. You might be dealing with shipping data. So you want address or destination code, stock tips. Could be stock codes. You don't know. But it has tons of extra attributes. Each one of those spans. Together, all the ones with the same trace ID, that's your trace. It's not that much more complicated than that. I mean, they're really just fancy logs. Or to put it another way, logs are basically boring traces. So what is a log then? Well, logs are point-in-time data by contrast. They're a thing that happened right now. But they're designed for humans. That's what a log is. It's designed for humans. We can add structure to them. We can put them in a JSON format and send them over. But ultimately, one of the things that differentiates a log from a trace is it has a property called message template, which is the human readable part. Now, they're essentially built for doing sort of local debugging that we then try and use in production to gain observability, which means they're kind of unintentional observability, if you like. Now, fun fact, we did an analysis of one of our logging customers recently, and about 10% of their logging volume, the message template said, here. They're unintentional observability. They are really good for things like startups and crashes, because we don't have a context, we don't have a trace at that point. The thing started up, the thing crashed. Why did it crash? The other thing they're really good at is debugging whether your tracing's working. But there's nothing bad about logs. Done well, logs are amazing. Canonical logs, wide context, using names and names of attributes that make sense and have consistency across wide systems. They're really, really useful. The issue with logs, though, is it's very, very easy to do them badly, as opposed to traces, which generally you end up falling into the pit of success much more easily. I mean, logs are fine mostly. So what is a metric then? Now, metric is two things. There's big M metrics, little m metrics. In IT, when we generally talk about metrics, we're talking about big M metrics. We're talking about time series aggregates. We're talking about these metrics-based systems, the Influx, Prometheus, M3, all of those systems that store a metric data point with some labels that go with them. That is what we were referring to when we talk about metric. But metric doesn't necessarily mean that. Metric can mean something that we measure. We need metrics. We need to measure things. We don't necessarily need metrics, if that makes any sense whatsoever. But their time series aggregates is what we're referring to as the signal within OpenTelemetry. Time series-based aggregates. It's a data point with some labels, potentially what we call bucketing, where we'll say a duration, we'll bucket it into certain buckets, so we won't have every single millisecond as a different data point. What we'll have is 0 to 100 milliseconds, how many were in that window. 101 to 500, how many were in that? We'll bucket them. So you don't get to know, was it 102 or 103 milliseconds? You get to know which bucket it was in. That's a time series aggregation. The thing is, they're incredibly cheap to store, which is why we were using them back in the day when hardware was expensive. They're also useful, because they're cheap to store, they're actually incredibly fast to query as well. Cheap to store, cheap to query, fast to query. What's not to like? The problem is they lack deep context. Going back to what Charity was talking about this morning, we strip a load of context off this data to make it cheap to store. Because if we add something like a request ID or a trace ID into a metric, we might as well have one metric data point for every single item that comes through. Just use a trace. Metrics are all about that aggregation point. They also lack that dimensionality and cardinality in each of those things because, like I say, if we add something like trace ID as a label to a metric, that's incredibly high cardinality because every single time it comes up with a new ID. They're not bad. They have specific use cases. Now, if you know what you want to measure up front, you know what dimensions are important to you, there are a small amount of dimensions, use metrics. It's the best thing for them. The problem is that now our production systems have become more complicated, where we've got, Monzo famously put out in 2020 that they had 1,500 microservices and they put their service graph out. It was like there's some disturbance through the force, all developers all over the world going, oh, that's terrifying. Because like I say, when I started out, it was box line, cylinder. And now all of a sudden we've got all of these different things and all of these interactions that we need to know when things go wrong. How? Why? Now, the best part about OpenTelemetry is this real magic thing called propagation. This is what allows us to think about different systems connecting together. Propagation is not actually OpenTelemetry. So propagation is this idea of correlation. Like we add something to the request so we can correlate everything together. We transmit a little bit of state so that we know certain things like sampling criteria and various other things. But it comes from something called the W3C trace context spec. It's not actually part of OpenTelemetry. And what it says is there are certain headers that you pass over, where you pass over what we call a trace parent, and the trace parent stores the trace ID in it. It stores the parent span ID in it, and it stores some sampling data, which tells us whether we're going to keep it or not. I'll talk about sampling at the end. Now, it also has something called baggage. Baggage is the footgun you never wanted. It is bad, dangerous, misused. And if you want to hear some stories about how bad it can get, come talk to me afterwards. But ultimately what baggage is the idea of being able to transmit some additional context between your services to influence your tracing data. Sounds simple? Think about a stock system. We're going to go and check stock in this other system. It'd be really useful if I know what the user ID was that was checking the stock, but I don't want to put that on my API contract because it's only for telemetry. Let's put the user ID in baggage. Get to the other side, take it out of baggage, put it on your, whether it's your spans or your logs. Really simple. It is not, however, multi-span attributes. I want everybody to take that away from this. Just because you add something to baggage doesn't mean it's going to appear on every span inside of your trace. Everybody believes it is, it's not. You can make it do that. There are baggage span processors that you can do, that do it. But that's where it does get bad. But again, this isn't part of OpenTelemetry. This is actually part of the W3C baggage spec by the W3C, which in the last few weeks has moved into the recommendation stage after 5 years. People think enterprises move slow. But again, it's part of W3C. It is, however, very dangerous. As part of propagation, propagation goes everywhere, depending on what languages you're using. Every third-party API call that you make over HTTP, it adds all the context on. All your tracing data and all your baggage data. Which means that sometimes, if you decide, well, it'd be really good to put the primary key of the user on here so we can use it in this other system. Yeah, sounds great. What do you use as your primary key? Oh, a social security number. You know that that's going to go to all of our third parties and they've now got everybody's social security number. It is very, very dangerous and should be really, really regulated in your organizations. But it is incredibly powerful, like most tools, with great power. So how does it all work? We have a few different ways that we would put this into our applications. They all revolve around something called instrumentation libraries, but how you get that in is up to you. Now, auto-instrumentation is what we refer to as agent-based. It's probably the most familiar for people coming into OpenTelemetry cold, because it's very similar to what you may have had with APM agents, where you install an agent on the machine or in the container, and it'll give you some default telemetry data. It'll assume lots about your application, like, well, everybody just writes a website with a database nowadays. That's all it is, really, isn't it? So you'll get HTTP information. You'll get your database calls, maybe your third-party API calls. And it'll assume a high-level set of information, the lowest common denominator, things like your request URL, the route, if you're using some kind of MVC framework, the database query, if you're running some database queries. The auto-instrumentation is basically codeless. Really good for like SRE teams who don't have access to change the code. They can sideload all this data in, use environment variables to configure it all, and they don't need to change the code at all. It is incredibly good for getting started. If you want to know whether tracing and logging data and metrics data out of OpenTelemetry is something that you can use, start with the agents. There's agents for Java, for JavaScript, for Python, .NET, Ruby. There isn't kind of one for Go. There is kind of eBPF stuff, but ultimately, it's incredibly good for getting started because you can get a wealth of information really, really quickly. It does, however, become very verbose because it's making a lot of assumptions about your application. It's a lot harder to tweak the data. But the other thing is you can't actually add additional context to that data. All those extra attributes, that extra dimensionality that makes tracing and logging amazing. You can't do that. It's really easy to do. I mean, this is an example of doing it in .NET. Download a file, use the file, add some environment variables. That's it. That's as much as you need to start sending telemetry data using OpenTelemetry. It's very, very similar in Java, in JavaScript, you use a require handle to add an extra require.js, which has some config in it. It's not complicated, but it's really, really powerful. But it's a precursor to you going to move to coded instrumentation. And coded instrumentation is where you start to add your own spans, where you start to add your own context to existing spans. You generally do it in something like an application startup. For .NET, it's an application startup. Same with JavaScript and Python. With Java, you still use the Java agent. That's the accepted path, no matter which way. But that's when you start then to be a bit more targeted. If you're using JavaScript, it is not useful to be able to see the file system calls of loading every single node module on startup. That will eat any budget that you've got with your logging provider, because has anybody seen a modern node modules folder? I did have a meme that I put up there of the black hole and the weight of the universe going through Node. It's not a slight on JavaScript at all, just a slight on Node modules. But it gives you full control. You can decide which spans you want to keep, which spans are useful, which context would be useful, which ultimately means you're being way more intentional about what it is. You're saying, this is a thing that is important to me as my organization. It's what differentiates you. Because the reason we as software developers write applications is because there's something unique about our organization. Because if there wasn't, it would be way cheaper to go and buy an off-the-shelf product. If you're building an e-com platform, ask yourself, why am I not using Shopify? There's probably some reason why you're not. And it's that uniqueness which is where things are going to fail. That uniqueness in your telemetry is what's going to help you and save you in those scenarios. Now, the other thing OpenTelemetry produces is something called the OpenTelemetry collector. Now, I used to be a telemetry collector hater. I was, no, in your application, send it straight to your back end. No need for a collector. I have since seen the light. The collector is all-powerful, and nobody should run without it. The collector is wrongly named because generally we deploy collectors as a proxy. Your applications send that telemetry data to the collector, and the collector will forward it onto your backends. It will do some processing of that data if you want it to as well. But it can take data from things like Kubernetes. It can take all your kubelet stats, or your cluster level metrics, put them into OpenTelemetry format and forward those over to your backends. It can do things like fanning out, sending it to multiple vendors. When you're in that renewal cycle and you're trying to work out, is there a better tool for this? Well, you can actually send the same data to 2 providers at the same time and do a bake-off. Some of the core things that I like about the collector: you can centralize your config. Now, in the example I was referring to before, where we've got 1,500 different microservices, and all of those are going to be starting to send telemetry to a backend. And that backend needs an API key. And then all of a sudden, somebody leaks that API key. And you're like, oh, we need to cycle the API key. And you can sort of hear the SREs crying in a corner. It's like, not again. With the collector, what you actually do is you send unauthenticated to your collector inside of your cluster, inside of your internal VNet or your VPC. And the config of where that's going to go, the API keys, are actually in your collector. So then when somebody goes up, we need to cycle the API key, it's like, I'll do it. It's going to take me 4 days. But it allows you to centralize that config. It allows you to centralize where I'm going to send it to 2 vendors at the same time in one location. Now, a lot of people run these in tiers. So you might have one that's close to your application, one that's in a shared network segment, and then one that's at a gateway location. The biggest one I've seen is 7 tiers of these things. Don't do that. 2's enough. The other thing that's really interesting about the collector is you can use it to secure egress. If you're running in, say, secure networking, zero trust networking, chances are your edge compute, where your application lives, doesn't have access to the internet. It's not supposed to. It'll be behind an ingress gateway, and then it'll be forwarded out through some kind of firewalled external traffic. And you go to the security team, it's like, yeah, can you open up these IP addresses? It's like, oh yeah, what's the range? 0.0.0.0/0. And the security team, once they've stopped laughing, will say no. What the collector allows you to do is put one location and say, this one location, can you make this one be able to access these endpoints? And they go, yeah, I can probably do that, but what day is it sending? You go, I'll let you decide. Because the collector actually has redaction and filtering capabilities. So your security team, you go, you can control it. And they go, what? It's like, yeah, just put some regex rules in there, filter out some data. If you see 16 contiguous numbers, that's a card number, don't send that. Let's not send first names, let's not send social security numbers. They can configure it to say, well, this vendor is a part of our GDPR scope, it's part of our SOC compliance. They can have everything, but this vendor over here that we use for this purpose, this one's only going to get a subset of telemetry. Walk to the security teams and tell them that, and they're like, this is amazing. And guess what? A happy security team makes for happy developers. And happy developers write better code. But it allows you to centralize all of this data, to be able to do redaction, to do filtering. It also allows you to do centralized enrichment, especially in a Kubernetes world. So your application doesn't need to say, I'm running on pod this, with this IP address, in this node, in this cluster. Your collectors can do all that for you. The collector is an amazing piece of kit. There's a few ways that you can deploy it. You can just, obviously in OpenTelemetry world, you can just send your telemetry straight to your backend. Don't do that. You can also just do it through one collector, and that's generally a good way to get started. Throw yourself a collector, throw the auto-instrumentation in your applications, throw it through the collector and send that out to your backend. As you start to grow in your telemetry pipelines, that's when it starts to get complicated. Throw a load balancer in the middle of it, auto-scale it out. Treat it like an actual appliance that you've got, an off-the-shelf thing. The collector is an entire topic that I have a 1.5-hour talk on, so I won't go into all the depth of that, but you get the idea. This is, you're building your debug experience, you're building your pipelines, you're the one in control. You're not just installing an agent from a vendor and saying, go do your thing. Now, final thing I want to talk about is sampling. Because as we all know, there is a cost crisis in observability right now. It costs a lot of money to store all this data. If we want to store the tracing data, which let's say a request goes through 3 different services, that's probably around 6 or 7 different spans that you've got for every single request that comes through your system. Sampling is how we keep those costs low while providing with the ability to debug your systems at the same level as you always have. There's 2 different types. We can do head sampling. We can do tail sampling. Both of them are about us retaining the full context of a whole trace or none of the trace. What it does is it reduces our storage costs, our ingress, our ingest costs, our egress costs, all of those things. Because it's reducing storage, it makes querying faster. It does a lot of things that are really awesome. Now, when we do head sampling, essentially we do it before the activity the user has done is created. Like maybe that's a HTTP request, or a message that's come in, somebody's dropped a file on an S3 bucket or a blob storage and you've triggered something off the back of it. But what that means is we've got very little information to go on. At that point, you maybe know the URL, the user agent, maybe the size of the payload, because you've got request length. But you don't know whether that's going to be slow. You know whether that's going to be a slow request. It could be one that errors. And the thing is, if you knew it was going to error at the point when the request came in, maybe fix the code first. But it is the most efficient way to do sampling because it removes all of the process overhead. Because if you're not going to keep the data, then don't generate the data in the first place. Take it off the heap. No need for it. But you only have limited information to go on. Now, by contrast, tail sampling is what everybody should be doing at scale. Now, tail sampling runs on a delay after you've received that first, the root span. So when the root span comes in, you wait a little bit of a delay, 5 seconds maybe, wait for all the rest of the spans to come in, and then you can make a decision. Generally run as part of the collector, or we have our own adaptive tail sampler that we use that sits after the collector. But it has access to all the span data on all of the spans. It can tell you whether one of your spans errored. One of your spans was a retry. It can tell you whether it was slow, which means you can make a decision on whether to keep it or not. It does, however, delay sending spans to the back end. That's a trade-off that you have to make. It is memory intensive as well, because it's having to store a load of that data, buffer all of that data up. But it is phenomenally useful. It does, however, require the application to send all of the spans. Now, if you're running in a multi-AZ environment and you're sending all of your spans from your 3 AZs to one location, that's 2/3 of your data that is going over cross availability zones. Now, if you're using a cloud platform that treats cross-AZ traffic as a revenue stream, AWS, then that can be quite expensive. These are all trade-offs. Is it cheaper for me to send it all to my vendor, my back end, or is it cheaper to stomach the cross-AZ cost and then send fewer items to your vendor? These are all decisions you need to make. This isn't a tool that's just going to be, let's just install it tomorrow and we'll be done. OpenTelemetry is a tool to help you achieve observability. It's a tool that you should be continually working with, adding context, maybe removing context when it's no longer useful. You should be constantly thinking about your pipelines, how you sample the data, what you use for sampling that data. Okay, so what's coming? Hopefully we'll have more semantic conventions signing off. There's about 3 years worth of bike shedding that needs to happen first. But we're signing off more and more semantic conventions, which means more and more libraries that you see will become V1 libraries and will be able to be used in environments where people care about that sort of stuff. They're all coming. Rest assured there are people that are sitting down in meetings, bored out of their mind, debating this stuff so it will get signed off. The first 2 that are coming up are the messaging and database semantic conventions. Those should be within the next few months. More libraries, doesn't matter what language you're in, all those instrumentation libraries that I talked about, whether you're using the auto instrumentations or the manual coding instrumentations, every day there are more libraries coming out for your languages that will provide opinionated telemetry for how you use those things, whether it's a HTTP client, whether it's a mediator library, whether it's Spring Boot. They're all coming out with new libraries that provide that opinionated telemetry so that you don't need to do that to get off the ground. Better documentation. Yeah, it's not great. I'm sorry. We're working on it. And the other thing is, we need to know what you want. One of the things that I do when I'm out talking about this stuff is I take the questions that inevitably I'm going to get today and take those back to the SIGs for all of the different libraries, for all of the different languages. We need to know what it is that's bugging you right now. Why is it that you are not using OpenTelemetry in production? So hands up, who's using OpenTelemetry in production right now? Oh, I'm disappointed in all of you. What I need to know is why. What can we do as the OpenTelemetry community to make it easier for you to adopt it? What's missing? Tell us. Whether you want to ask a question at the end or whether you want to come up and rant at me later, it's fine. I can take it. Come and rant. I can rant back at you. But that's what we need to know. There's tons of stuff coming from making it easier to run in asynchronous contexts, running in serverless functions, whether that's Lambda, Azure Functions, Cloud Functions. They're all coming. But the more you tell us, the more we can focus. I would be remiss if I didn't say that we have Honeycomb. We have a free forever account. You can come and try this out. It is actually the easiest way for you to get started because you can just use an email without a credit card or anything like that, install your agents and start sending the data straight away. We also, Charity and some others, literally wrote the book on observability engineering. It is a free download on the site. Go and have a look at it. It's not about Honeycomb. It's about observability in general. Go and have a look.